Hello friends, welcome to Learner's Planet. Friends, this is our 9th session for set theory. I hope you are enjoying the sessions of set theory, and I'm sure now you will be able to find the topic so easy and interesting. Okay, so let's begin this session. Just get ready with your paper and pen. Now we see this question. A is this, B is, and C is given. Then A minus B cross B minus C we have to find out. A minus B means what? Only A, right? So from A and B, if we deduct A intersection B, we will be getting A minus B. That is this portion, right? That is only A. So that's 1 to 4 and 2, 4, 5. That means 2 and 4 are common between A and B. That means only A will be 1, right? So A minus B is 1. Cross B minus C. B minus C means only B. So 2, 4, 5. So 2 and 5 common between B and C. So B minus C will be only 4. Right? So we have to find out the Cartesian product of 1 and 4. So that is 1 and 4 ordered pair. Okay? So this is the correct answer. Okay? Do not get confused between this and this. This is just a element, right? But actually this will be a set. So set we represent between this two curly brackets. Okay. Now ABC are non-empty sets and A minus B union B minus A. Now that's pretty simple. Just draw two circles. This is A, B. This is A minus B and this is B minus A. So A minus B union B minus A, that means this complete portion, right? So if we take the complete both the circles, that is A union B, so from that we need to deduct this portion, and this portion is what? It's actually A intersection B, right? So from complete A union B, if we deduct A intersection B, then we will be able to get A minus B union B minus A, right? So A union B, this complete circle, a combination of two circles minus this is A intersection B, right? So this is this portion plus this portion, that is A minus B union B minus A. So this is the correct choice. I'm sorry, not this, this. Yeah, A union B minus A intersection B. This is the correct choice. Okay. Now see this, A and B are sets, A intersection B minus A. That's A, that's B, that is B minus A is this portion. Now B minus A itself means it's only B, right? No A is there. B minus A is this portion, right? And A is this complete portion. Okay. So can you see anything common between A and B minus A? No. Right? So A intersection B minus A, it's a null set. Okay, nothing is common between these two. B minus A itself means only B. So if it is A and intersection only B, then nothing can be common. Now we see this, A and B are two sets, A minus B union B minus A union A intersection B. Okay, so that's pretty simple. That is A minus B, this is B minus A, and this is A intersection B, right? So precisely we are taking all the three things together. That means we have to take this circle plus this circle. So that's A, that's B. That means the combination of both the circles will be A union B. So this is nothing but A union B. Okay, so if you are conceptually clear, if you are able to draw Venn diagrams, then you can solve this sort of problems very easily. Right? Now this, if A is any set, then, now say this, this is the universal set, this is A and this is A dash. A dash, that means outside portion, right? And this is universal set. Now A union A dash is 5. No. A is this and A dash is this. So A union A dash will be actually U. Right? A is this portion, A dash is the portion outside the circle. So precisely this portion plus outside the circle is the complete universal set. So it's phi, it's wrong. So A union A dash will be actually U, that is universal set. A intersection A dash is U, that's wrong, because A is this portion and A dash is the outer portion. So nothing is common between the two, so it will be a null set, right? So only option B is true. Okay. A and B be subsets of set X, then A minus B is equal to A union B. A minus B is equal to A intersection B, A minus B is equal to A complement intersection B, and A minus B is equal to, precisely we have to find out A minus B. So I draw two circles, that's A minus B. So this portion, only this portion, that is A minus B. So A minus B is A union B, that's wrong. A minus B is A intersection B, that's wrong, because this is A intersection B, right? A minus B is A complement intersection B. Now A complement, that means this area, right? But we want this area, so it cannot be correct, right? A minus B is equal to A intersection B complement. Okay, this is the circle of B. So B complement is this, right? That is B complement, right? And this complete circle is A. This complete circle is A, right? So this portion is actually what? B complement and common portion of A, right? So it's B complement intersection A, right? See this area is B complement and this is only A minus B, so it is B complement, and from B complement if we take the common between this complete A and B complement, then we'll be getting A minus B. So this is correct. Okay. If A and B be two sets and A intersection B whole dash. Okay, so this is the universal set, that's A, B, this is A, B, and this portion is A intersection B, right? Now we have to find out A intersection B dash. A intersection B is this portion, so dash will be the entire remaining area except this particular portion. Right, now we try to match the definition from options. That's A dash intersection B dash, the first thing. So A dash will be this area outside this circle, and B dash will be area outside this circle. So that is not correct, because in that case this portion, that is this portion and this portion will be eliminated, right? So that is incorrect. A dash union B dash. So if we take A dash, then this complete area outside this circle, the complete area will be taken up. B dash, that means outside this circle the complete area will be taken up, right? That means this complete area is also calculated and this complete area is also calculated, right? So A dash union B dash will be the correct explanation of A intersection B whole dash. And that is De Morgan's law also, and we have already established the same. I can do just it for you once again. I suppose X belongs to A intersection B. That means X doesn't belong to A intersection B whole dash, right? So if X belongs to A intersection B, that means X belongs to A and X belongs to B. Right, that means X doesn't belong to A dash and X doesn't belong to B dash. So X doesn't belong to A dash union B dash, right? So X doesn't belong to A intersection B dash and X doesn't belong to A dash union B dash, right? So we can get the same answer, that is A dash union B dash. Okay. if A and B are two given sets, then A intersection B complement. Okay, so this is the universal set. That's A, that's B. This is A intersection B, right? So A intersection B complement is this entire region. Okay, entire region. So precisely it is universal set minus A intersection B. Universal set minus A intersection B. This, right? So A intersection B whole dash is this area. Okay. Now we have to find out the common area between A and A intersection B whole complement. So I have already drawn A intersection B complement. Now I draw A. So A will be, I just change the color. A will be this complete circle. Right? Now you can see the common area between A and A intersection B complement, the area which is having green line as well as red line. So that is this portion. Right? So this portion is actually what? It's only A, or we can say A minus B. Since we don't have A minus B among the options, so let's check this one because all of them are incorrect. A intersection B complement. So I see A is this complete circle and B complement is this entire region. So A intersection B complement will be nothing but A minus B. Okay, so if you use Venn diagrams to solve these sort of equations, it will be really very easy for you to do the problems. Okay, you can have the 2-3 color pens, or you can draw horizontal and vertical lines to see the common area. Okay, now A intersection A union B whole dash. So again I draw the universal set. That's A, that's B. A union B is this complete portion, so whole dash will be this remaining area. That is A union B whole dash. Okay. Now A intersection A is this portion. Okay. A intersection A union B whole dash. So you can see A is this portion and A union B dash is the outside portion. So nothing is common between A and A union B whole dash. Right? Nothing is common. So it's a null set. Okay. Now see this. In this case we have to find out A intersection B dash. Okay. So B dash is what? Except 6, 7 all the elements will be there. So A is 1, 2, 5 intersection B dash. B dash means 1, 2, 3, 4, 5, 6, 7 we don't have to take, 8, 9, 10. Now we have to find out the intersection of these two. So 1, 2 and 5. So 1, 2 and 5. That is nothing but A itself. Okay. Now this in set A, x such that x is multiple of 3. So set A is 3, 6, 9, 12, 15, 18 and so on. B is equal to, B is x is multiple of 5, 5, 10, 15 and so on. Right? We have to find out A minus B. And A minus B, so precisely that is only A. So actually A is having the elements multiple of 3 and B is having the elements multiple of 5. That means A intersection B will be having common multiples of 3 and 5, right? So 15 will be here only, 15 will be here also and here also. So all the multiples of 15 will be there in set A and B, right? So A intersection B will be 15, 30, 45 and so on. Right? So what we want? We want A minus B. So A minus B means what? We have to consider all the elements of A and from that we need to deduct the elements of B. A minus B is actually only A. So let's see, that's A, that's B, that's A intersection B. Now we want A minus B. So A minus B is actually this area. Okay, this area is A minus B. Now we see from options which of them suits over here. A complement intersection B. A complement intersection B. A complement is the area outside this circle, so that cannot be correct. We want the portion of A. A intersection B complement. Okay, so B complement is this B circle. Outside this is B complement, and this complete circle is A. I wrote, so that's A. So common between these two is this portion, right? This portion only, and this is what A minus B. So A minus B and A intersection B dash, both of them are same thing. Okay, getting my point? Now we see this question, and here we have to find out this value of this expression. To be able to solve this sort of questions, what you can do is you can assume the values of A, B and C. Suppose A is 1, 2, 3, 4, B is 2, 5 and maybe 6. There should be one extra element which is not common between A and B, so we can distinguish it clearly. And here we take 2 and then 5 and then 7, right? So something is common among the three, something is common between these two, and something is common between these two. So we'll be able to find this out easily. A union B union C. So A union B union C is what? 1, 2, 3, 4, 5, 6, 7. That is A union B union C. Now we have to find out intersection of A intersection B dash intersection C dash. So A is 1, or I just do it right away. B dash will be 2, 5, 6. I eliminate 2, 5, 6. So it's 1, 3, 4, 7. 1, 3, 4, 7. That is B dash. C dash is equal to 1, 3, 4, 6. Okay, so that is C dash. So A intersection B dash intersection C dash. So 1, 2, 3, 4, 1, 3, 4, 1, 3, 4. So 1, 3, 4 is common, right? 1, 3, 4 is common among A, B dash and C dash, right? And we have to find out the dash of 1, 3, 4. So 1, 3, 4 dash is actually 2, 5, 6, 7, right? So this expression 1, 2, 3, 4, 5, 6, 7 and 2, 5, 6, 7. So it will be 2, 5, 6, 7, right? So up to here it is 2, 5, 6, 7. Now we have to see intersection C dash. So between this and this 2, 5, 6, 7, 1, 3, 4, 6. So only 6 is common, right? So that is 6. Okay. So we are getting the answer as 6. Now we just match by options. B intersection C dash. So B is this and C dash is this. So what is common between these two? 2, 5, 6 and 1, 3, 4, 6. Only 6 is common, right? So this is the correct choice. Okay, because in this case also we are getting 6 and previously we were also getting 6. Okay, so this is how you can solve this problem. Now if A and B are disjoint, then number of elements in A union B. So if they are disjoint set, nothing is common between these two, then all the elements of A plus all the elements of B, that is NA plus NB, that will be A union B. And this, if A and B are not disjoint, then number of elements in A union B will be what? That will be the diagram. So A plus B minus common area, right? So NA plus NB minus A N of A intersection B. This is the correct choice. Okay. Now NU is 20, NA is 12, NB is 9, and A intersection B is this, and A and B are subsets of then A union B whole complement. Okay. So first of all we find out A union B, number of elements in A union B. So that is NA plus NB minus NA intersection B. So 12 plus 9 minus 4. So 12 plus 9, 21 minus 4, 17. That is number of elements in A union B, right? So number of elements in N and A union B dash will be, out of total 20 elements, 17 elements are in A union B. So remaining 3 will be there in A union B complement. Okay, so that's pretty simple. Now, N number of elements in universal set is 700, NA is this, NB, and A intersection, then A complement intersection B complement. Okay, so A complement is actually out of 700. If we deduct 200, what we can do is we just draw the Venn diagram. That would be rather better. So that is A, that is B. So common is 100, right? Then NA is total 200. So if this is 100, this is 100. Then B is 300. So if it is 100, it is 200, right? So this is total A union B. A union B is 200, 300 and 400. Okay. That means remaining 300 we are having outside. Okay. So A complement means this entire portion. So that is A complement. And B complement, I just change the color. B complement is this entire portion. Okay, now A complement intersection B complement. So we have to find out the area that is having maroon line as well as green line, right? So that is this area, right? That is the area outside both the circles, which is having a maroon line and green line, right? So that is actually 300. So number of elements in A complement intersection B complement will be 300. Okay. If A and B be two sets containing 3 and 6 elements respectively, then what can be the minimum number of elements in A union B? And find also the maximum number of elements in A union B. Okay, that's pretty simple. Minimum number of elements will be 6 because B is having 6 elements. See, if all the elements, 3 elements of A are common between A and B, then A union B will be B only, right? If A intersection B is A, then A union B will be B, right? That means all the elements of A are there in B. So in that case, minimum number of elements in A union B will be B, right? So this is the situation. This is B and this is A. And maximum number, that means nothing is common between A and B. They are two disjoint sets. So in that case, the 3 elements of A plus 6 elements of B, right? So in all, A union B will be 9, right? So minimum number of elements in A union B is 6 and maximum it is 9. Okay. If NA is equal to this, NB is equal to this, NA minus B is this, then number of elements in A union B. Okay. Draw the circles. This portion is 47 and this complete circle is of 115. So if it is 47, this portion will be 115 minus 47. So that is 68. Okay. And number of elements in B is 326. So if this is 68, this portion will be 326 minus 68 and that is 258. Now we have to find out number of elements in A union B. Since these two are not disjoint, so total number of elements will be 47 plus 68 plus 258. So we can say 47 plus 68 plus 258 is 326. Okay, because that is complete B. So 6 and 7, 13, 4, 5, 6, 7, 373 will be the correct answer. Okay. So friends, I hope you might have enjoyed this session. In the next session, we'll be taking more problems based on set theory. Do revise this session and the previous ones. Bye-bye.